we're going to be using a technique that was pioneered by the US government in the 1950s. So, it's going to be a little different. So, you need some uranium. It's not as hard to come by as you thought. You can dig it out of the ground. It's 40 times as abundant as silver. So, your backyard has a little bit of uranium, but you're going to need a lot. And uranium comes in 2 flavors. Most of it is the wrong flavor, okay? It's only 0.7% the right flavor. We need, for our little project, 4% of the right flavor. So how do we get it to the right flavor? We need to enrich it. So going from 0.7% U-235 to 4%, it's called enrichment. It's really hard, it's expensive. You need a giant factory full of these gas centrifuges. But once you have your enriched uranium, you can make it into uranium dioxide and shape it into a little fuel pellet. This is like 7 grams in weight. And it's a little pellet, you bake it in a kiln, it's a ceramic. Then you line them up in a long zirconium rod. You get a whole bunch of these. You line up all these rods into a giant square stack, and now we have the fuel for a nuclear reactor. So we just need to find a nuclear reactor to put it in, right? Well, I'm sure not all of you have access to one. So you might need to cut through a little red tape to get to one. NRC likes to control who builds nuclear reactors. In fact, they do a very good job of it. So what happens in the reactor while you have your uranium-235 atom? You smack it with a neutron. They have a little fight, and you get some fission fragments. The uranium atom splits apart into 2 new atoms, we call them fission fragments, and you get some extra neutrons. Those neutrons go on and smack other uranium-235 atoms, which split apart and make more neutrons. Those neutrons fission more uranium, and so on and so on. And gosh, this sounds like it's getting out of control, right? We're just going to make more fission, more neutrons, more fission, more neutrons. But we can control it because we have control rods. So the control rods are just made of a material, usually boron or cadmium, that is really good at absorbing neutrons, but it doesn't do anything. Well, it becomes radioactive, but it doesn't emit more neutrons. So these fission fragments, they have a lot of energy. They have about 400 million times the thermal energy as a molecule of gas in this room. They are hot. So we can use that heat to boil some water. We're done, right? Awesome. But if you boil a lot of water, you end up making a little bit of steam. Well, what are we going to do with all that steam? Well, we can harness the energy in that steam using a steam turbine. So you spin this turbine, it spins a generator. Basically, whenever you have a spinning thing, you can make electricity. It's pretty awesome. It's kind of a plus. But where was that water relative to the reactor fuel? Well, the reactor fuel's in this giant steel tank called a pressure vessel. So you put some hot water in, and you get some really hot water out. Some of you might notice that water boils at 100 degrees C, that water's pressurized. So you take that hot water, you run it through another device called a steam generator. It makes some steam, you put that steam, you turn the steam turbine, turns the turbine, turns the generator, makes electricity. We can use that electricity at Niagara Portland, or we could use that electricity to make some toast. So about 20% of the electricity in the US comes from nuclear power. If we were in France, 4 out of 5 slices of toast would be made with nuclear power. I haven't told you about the dirty dishes that we made to make this electricity. There are a few. So when you fission uranium in your reactor fuel, you make some byproducts. We call that spent fuel. What's in that spent fuel? Most of it is that uranium that was the wrong flavor to begin with. It doesn't really do anything. You have a little bit of U-235 left. You have those fission fragments, and we make an element you may have heard of called plutonium. Just a little bit. So that stuff's all radioactive, but we can store that safely. We need to store it very carefully, but it becomes less radioactive and less dangerous over time. So we've been using nuclear power in this country for over 40 years. And whether or not we're going to continue to use it for another 40 years is still a lively debate. So you may recognize this power plant.